is
Okay,
true.
let's take a look at those first. Let's
Sure.
see.
Okay, I think.
I think it's
Uh,
string join onwards. Okay, let's see.
I don't remember what what I did last time. Oh, yeah, yeah. String join. End this
Looks good.
together. I might have just done X20 might have been the only thing that's still outstanding. I think I had done
For
including
string
X.
join, there is another way. In the documentation, you will see that a plus sign is equivalent to string append. So, for example, like A plus B is the same thing as string append AB, right?
Okay.
So what you could also do is um, string one plus underscore plus string two, like that. You see that on line 135?
I feel like I maybe tried that and then ended up there. I'm not sure though. I think because that's naturally probably how I usually might handle strings. I would usually use append with arrays.
Hmm.
Um, but I landed there.
But yeah, that's one other solution, but what you did is also fine.
hmm
Let's see, string insert, 0 to I. What you could notice how this overlapping work between string join and string insert. You see that?
No, I'm sorry.
So string insert, you're adding an underscore, right? Between two strings,
hmm
which is precisely what string join does.
Wait. Oh. Oh, okay. You're talking about the two. Okay, I see. Now I see what I didn't know. Like, what are you talking about string insert? Um, I had more trouble with this one, I think. Insert. Find the function. It's a number in. Zero I. Oh, okay. Yeah, this is like I had to slice up to a certain number, right? Or no, I think I chose to do it that way. We define a function, string insert, which consumes string str, I inserts in the int. Yeah, okay. So, okay, all right. I kind of sorry. I think I had to catch up a little bit. What is it that you want to show me between these two?
So string insert, it's adding an underscore between two strings, right?
Yes.
And that's exactly what string join does.
Okay. So you're saying I should have used string join for string insert,
Yeah, you could.
or
It works either way, but that's ideal. Yeah.
I guess I thought of them. I didn't think of like, oh yeah, I can use my prior functions for the next exercise. I guess I thought of them as like separate exercises, if that makes sense.
But yeah, no, you can use any function you have written in the past.
Okay.
All right. And a habit I want you to have is also to try to come up with the simplest examples and then work your way up. So for string insert, like having a string, an empty string, for example, a string with one character. You know what I'm saying?
For my test. Yeah.
Yeah. Same thing for string join as well. You could also have an empty string for one of them or both of them. Yeah.
Yeah.
Okay. And let's see, exercise 20. Yeah, looks good. Yep.
That was the one. String delete. This the one? Trying to think like that. I remember like inserting wasn't too bad, but for some reason deleting kind of gave me um Yeah, it took me a little bit to do this one. Wasn't like terrible, but
So I'm writing you some notes at the bottom as well, just so you can refer to it. Uh, for examples and tests, make the simplest possible example and work your way up and gradually work your way up in complexity. So an interesting property about this is if you notice string insert can actually take in an empty string, but string delete cannot. I don't know if you noticed that.
um, it makes sense because then what are you deleting?
Yeah. So making like very simple test cases like these like unearths the concepts behind these functions, behind the nature of the problem. Yeah.
Okay,
So yeah, this is my two feedback, but yeah, good work. So we're gonna move on now. All these exercises are just to get you comfortable with working with functions, working with variables, and so on. Um, so we're gonna move to a different idea, and I'm gonna go to the one-on-one file now.
okay.
Okay. Oh, all right, yeah. I already started with you on this.
Oh, you mean
The traffic
you,
light.
yeah, you kind of brought it up like, hey, just like a taste of like, hey, this is what we're gonna go through enumeration.
Yeah. Okay.
And so like I
Uh, I'm actually
go
gonna
ahead.
pause the enumeration for a second. I'm gonna, okay. I'm gonna do the same idea for design recipe, but not on a more complex at a time. I'm gonna do it on something very simple. Let's say I'm gonna use temperature. So I'm gonna talk about temperature now and it being a number. Remember in the first session, I was like, oh, look at this five. What does five mean? Five doesn't mean anything, but 5 degrees Celsius does.
Yeah.
So, it's this idea between converting between the two worlds, that's information and data. Our job as programmers is to convert information to data and from data back to information. And we've saw some functions that we can do that performs operations on data. And this is the foundations of everything we'll do. And the way we can systematically do this and solve problems is by using the design recipe. So when we say this, what is design? Design is going from A to B systematically. And recipe is a series of steps you can follow. It's like cooking, when you're cooking, you follow a recipe. So, uh, so we're gonna go through this idea of systematic design, and we'll begin by showing the data definition design recipe. That is, how do we come up with data definition systematically? A data
Okay.
definition is um defining data definition defines the relationship between some information and its corresponding whoops, data representation. So, so some things to break down here. Data representation refers to how the computer encodes a piece of information. So, for example, a number is a data representation, Boolean, like all the primitive data types that we've covered so far are data representation. And as we move through these sessions, we're going to learn more interesting forms of data representations that can allow us to do more interesting things. But for now, we have the atoms, the very simple things, number, boolean, strings, and images. Um,
Mm-hmm.
Another set of data representation is what does it mean? Like if we write the number five, like what does it mean? The idea of what does it mean, we call this the interpretation. What does the representation actually mean? Okay. So we
Yeah.
have two coins here, how the computer understands it and how the humans understand it. So in summary, how the computer understands versus how the human understands. So we're going to demonstrate this with a very simple data definition, which is temperature, and it is just a number. I'm demonstrating with this very simple example, and I'm going to do this for you. So this just actually you just have to watch and listen, and I'll ask you some questions. But we're going to apply the same principles into enumeration. That one I'm not going to write much for you.
Mm-hmm.
Okay. Temperature is a number. So line 15, a temperature is a number. We call this the data representation. We are choosing to represent temperature as a number. Okay.
Yeah.
Uh, Next is the interpretation. So how hot, oh, I'm just gonna say like the temperature. Whenever you're dealing with numbers, it's common to specify units. So for example, like in degree Fahrenheit. Um,
Mm-hmm.
it's a good habit to have to specify the units. So this is the first two steps of the design recipe. So for data definitions, number one is what is the data representation? The second step is what is the interpretation? So again, for computer, and this one is for human. Okay? Following me so far?
Yeah.
Next step after this is, oh, I just realized did I share my screen? Oh, I didn't. Okay.
No.
Whoops. It's for the recording.
Sure. Oh, yeah, that makes sense.
Yeah, yeah. So forgot about that. Whoops. Okay. The third step is the examples. Um, so what are examples of this data definition? So to use examples, we just declare globals for now. So for example, I'm going to do T for temperature and then some number, let's say 3. And then I'm going to add the
Okay.
units as well, F. So 3. So this is an example of temperature. Can you give me another example for temperature?
Sure. 20C. Or is that
20.
too
Okay, let's
specific?
stick to Fahrenheit for now. Let's just stick to one.
Oh, sure. 20F.
Yeah, it's 20F. Okay. Okay, now let's aim for more interesting example. What are some interesting numbers?
Was it like negative 32 degrees Fahrenheit when it's where
What,
water freezes, right? I'm sure.
32, is it?
No, it's 30. It's yeah, 32. My bad.
Yeah. What are some other interesting examples?
Um, I don't know if you want like general buoyant, like very nice 75 degrees, 74 degrees, or
Okay.
72.
So I think about an interesting property about numbers is that they are negative numbers, right? So I'm gonna give you
Yeah,
this one, like -5. What are some other interesting things that we can do with numbers? Not things we can do, but like interesting
decimals.
numbers. Decimals. So yeah, how about like 5.4, right?
Okay.
Okay. I'll leave it at that for now, but when you're coming up with examples, try to like get all the cases. Oh, there's actually one more case that we're missing. Is there a number you could think of that would be very interesting?
A repeating number,
Sure. Okay. So like what would be a repeating number?
like 0.333, like point 0.3 repeating.
Oh, okay. I'm just gonna do
I mean, I've like this. That's the word presentation. That's fine. You just that also came to mind.
that's actually so in this language we can do this.
Hmm.
You saw what I wrote 1/3.
Yeah.
Yeah.
Yes.
Not all languages allow you to do that. Some languages will just compute the fraction.
Okay. Hmm.
Okay, what's another interesting number? The very simplest number.
One?
Oh, actually, one is a good ex. I wasn't thinking of one, but one is actually a good
Unless you
number
mean
to
like
have.
zero.
0, yes.
Zero is very interesting.
Yeah, 0 is an incredibly interesting number. For example, like you can't divide by 0, right?
Hmm.
So
Yeah.
0 is an interesting edge case in arithmetic. When you're dealing with numbers, always have 0. Always. Okay, so that's the third step of the design recipe. We have examples. The last step, we shall save it for next time. We'll revisit the idea of the last step. Okay, so this is the data definition for the design recipe. Sorry, the design recipe for data definitions. I know this looks very easy right now, but as we move on to more complex data representations, this will be more interesting. So bear with me.
Sure. Yeah, cool.
All right. So next we are going to cover the function design recipe. So data definitions, the data, they're just what? They're just things, information. But what can we do with them? That's why we do computer programming, right? So we can perform operations on data.
Mm-hmm.
So how do we write functions systematically? So the first step is I'll give us a situation. I'll give us a task. So let's say I'm trying to convert temperature from Fahrenheit to Celsius. I think I misspelled Fahrenheit. Such. Okay. So let's say that's our task. Um, and what do we do? So the first step of the design recipe is you want to write the signature of the function. What's the input and output types? So in the case of convert temperature Fahrenheit to Celsius, it's clearly taking in a temperature.
Mm-hmm.
And for now, I'm just going to say it produces a number that's supposed to be Celsius.
Yeah,
So
either
that's,
integer or float.
yeah. And the signature, this is how the computer understands our function, inputs and outputs, which is basically what a function is, right?
Mm-hmm.
So it's back to this idea of how the computer understands a function. The next step is the purpose statement. What does this function, what is the purpose of this function? What does it do? So this is for how the human understands it. So in the case of temperature to number, uh, gets the Celsius of the given temperature, the given Fahrenheit temperature. Okay, right? So that's how the human understands it. Now, the computer, all it understands is like it's doing stuff with numbers, but as a human, we know, oh, it's performing uh, some translation and converts Fahrenheit to Celsius. Okay.
Mm-hmm.
Next, we have examples slash tests. So this is where we come up with examples, but unlike just examples for data definitions, we can actually run it as tests, which we have been doing in the past. Uh, so at this point, I am actually going to write a stub that's just a function without its implementation. So I'm going to call this Fahrenheit to Celsius. It's going to take in Fahrenheit F, and I'll write the test. Okay.
Okay.
So what's cool about this is that we can actually make use of the interesting examples that we have used in the past. Sorry, that we have made in the past. So for example, 32 Fahrenheit is 0 degrees Celsius. Um, what's some other interesting ones? So zero, and then we can do zero. So I would always like to have a test case for zero. I'm actually going to pull up a online translator. I don't actually know the formula off the top of my head. I used to.
Oh, yeah, me either, but that's easily Googleable. Cool.
Fahrenheit to Celsius. Okay, I found the formula.
Yep. It's what Celsius is Fahrenheit minus 32 times 5 9 or yeah, 5 9. Yeah.
Okay, so zero would be negative 32 times 5 over 9. What's interesting about test cases, I don't know if you've done this in the past, but we can actually put whole computations inside the tests. Uh, so I'm just going to do that because I'm lazy to figure out the decimals.
Sure.
Well, there's also one more. Let's have a negative in there. I think it's good to have some mix. So we have negative 5 Fahrenheit to Celsius. I can write that. Um, so this would be negative 37 times 5 over 9. There's also 1 Celsius that gets back itself. Uh, Number where Fahrenheit. I'm just googling
Where,
this.
where they're the same.
I think negative 40. Yeah.
Sure, I I wouldn't know to be honest. You bring it up, it's like, yeah, that's probably true.
Yeah. So uh, test is also a good time to figure out what are the interesting properties of what you're writing. So interesting property of this function is that for negative 40, you get back negative 40,
Cool. Yeah.
right? Okay,
Mm,
so now that we have the tests, finally, the last step of the design recipe, write the body of the function. I will modify step sheet and say that write in the stub. That's in order to write examples in the first place, you need the name of the function, right? And the parameters.
yeah.
So notice here I have like everything written in except line 47 is just dot dot dot. So when you're on to writing examples and tests, I always like to do this. Just write everything except the body, just leave it as dot dot dot.
Hmm.
For the body, I basically ripped the answer from the internet, which is just f minus 32 times 5 over 9.
Yeah.
So if we run this, let's see. All tests passed. Okay. Does that make sense? Good so
Yes.
far? So what we've done is we've applied the design recipe on atomic fixed size data. Um, so we're gonna do it. We're gonna apply the same thing, but with a more interesting data representation. The next thing we'll now do is enumeration. So I'm gonna type less now, and I'm gonna want you to do a lot more typing.
Sure.
So I did the easy part, and I'm saving the more interesting parts for you. We're going to go into enumeration, and I
Good.
want you to now follow the design recipe. So the first step of the design recipe is data representation. I see that we have written traffic light already. Um, so that's the first
Okay.
step done. What's the second step for the design recipe for data definitions?
Uh, what is the interpretation? Wait, no, sorry.
Mhm.
We was signature of the function and then purpose statement.
So let's deal with one of it, one at a time. So let's deal with interpretation. Can you write the interpretation for traffic light?
Okay. Interpretation of traffic light. Um, so like how we understand it is traffic light is a light that has three different colors that symbolizes when it's okay to go stop and when a red light's coming, basically.
Perfect. Let's write that down. Let's see at line 67.
Okay, cool. Okay. Yeah, I'd probably run that through ChatGPT to make that like makes more sense to other people. But yeah,
That's good.
that's my little definition.
No, that's good. That's good. Okay, so what's next after interpretation?
Sure. After interpretation are examples of the
Okay,
data definition.
let's do examples. What are some examples for traffic light?
I guess it would be these three, right? You want them
Yes.
in variable form?
Yes. And I'll explain why in a moment, but yeah, let's have it variable form.
Okay.
Okay, so yeah, and I don't have them in a comment, so you have to put that past line 71.
Okay.
Yeah, because we actually want to refer to them.
Yeah, no problem. Let's just call it. All right.
Great. Also, just a habit to have, let's capitalize all the words. So like TOP, all should be capitalized.
Okay. Uh, why is that? I've never heard
It's a
anyone
convention.
recommend. Is this a
Like
convention specific to? Is this like across all languages? Like, tell me more.
most languages. So when you're writing like things that don't change, constants,
Okay.
typically you write them in capital letters. Is to tell people like this is something that doesn't change.
Well, that's true because they only have really constants in this language, don't they? Because you can't really change these later.
Yes. So these really are. So I don't have been calling them variables, but yeah, they truly are just constants. I usually use the words identifiers. I've been pretty sloppy with my vocabulary, but yeah.
Um, no, yeah, because like I learned about variables and constants in JavaScript, but Python, I don't really remember like that being so much of it. Like everything were variables in Python.
Yeah. Yeah, Python you can change anything. Okay,
So
so let me explain why I ask you to write them in variable form. The reason is because when you're dealing with data definition, you're going to use its representation a lot, right? Like you're going to write rate so many times, right?
yeah.
For various reasons. But what happens if we typo like this? RDE. What happens?
Um, you know, it won't be correct. And it depends on the context.
So this is the worst kind of bug. The programming language is not going to tell us, oh, you misspelled rate. It's just a string. It doesn't know if it's rate or
Yeah.
not, right? But what happens if
Yeah.
I do like TPO? Like I typoed hop.
Good point. Yeah, it'll tell you like, hey, that hasn't been identified
Okay. So a reason for
or
using,
defined.
I'm gonna write some notes here. A reason for using constants, variables for, I'm just gonna say constants for examples is so that we get help from the programming language when we typo. Uh,
Got it.
here's another reason. What happens if we are changing our data definition so that um, we're trying to do traffic lights for, let's say, Japan. If I'm not wrong, Japan doesn't use green, they use blue, right?
Mm-hmm.
So let's say we want to change green to blue, and we have like green written all over our code base, like green, green, green. You know what I'm saying?
Yeah.
We have to change all of them. But what happens if we just use bot for everything? Bot, 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 bot. We don't have to change the bot, right? All we got to do is just change line 74 and line 66. Just two places. See what I did
Yeah.
there?
Mm-hmm.
So I'm going to undo my changes here. So another observation we can make is if we decide to
Um,
change the underlying data representation, we only need to change uh, one or two lines rather than locate all the strings in the entire code base, which could be millions of lines of code, by the way. Okay?
mm-hmm. Okay. But like, oh, real quick. When you made that sentence, I just saw it. The reason why using constants for examples is so that we get help from the PL. What does PL stand for?
Oh, programming language.
Okay, okay. Thank you.
There we go. All right. Um, think I might leave it at there for. Oh yeah, another observation we can make, and this is specific to enumeration. For enumeration specifically, there's a finite set of elements for that data definition. So we can only come up with so many examples, right? Like I can't ask you to come up with another example, right?
Yeah.
Yeah. So for enumeration, always exhaust that finite set. Always list every single possible value for that data definition. Okay?
Okay.
Yeah. All right. So we have done the three steps of the data definition recipe. The fourth step is a secret still. Let's now go do functions. So I'm going to give you a task, and I'd like you to write a function based on the design recipe to achieve this task. I would like you to design a function rotate, rotate traffic light that
Okay.
makes green become red, yellow become wait. Sorry, green becomes yellow. Yellow becomes red, red becomes green. All right. What's the first step of the design recipe?
Um, okay. So, first step is what is the data representation? So for the computer, the strings. Um, and then you said interpretation. I think we kind of went over that. And
So
then,
let's focus on the first step for now, which is the data representation. But remember, this is for the function, so you have to look at the design recipe for the function.
okay, sorry, I think I misunderstood. So you want basically start putting the function together. Let's see. Traffic light. We'll leave that like that for now. Okay, like I get the command, but what's the input here? Is there an input? Or just like if I call this, you just call it both and then it does it.
So yeah, what is the input? Is there an input?
Um, I know, no, not really. Because these are always constant. The red, yellow, green,
Okay,
right?
so in order to make green become yellow, yellow become red, red become green,
I guess
where does the
you want
red,
me to
yellow?
you want me to put in those three elements then, basically, or those three?
Yeah, so I'm
Um,
more asking what should this function take in? Should it take in anything at all?
um, it's oh this I don't know. It's so weird because I feel like if I feel like if I had like more context, I'd know. This is so like hypothetical, I guess. I know what I'm doing as a concept, but like, oh, do you want these? Do you want red, yellow, and green brought in as inputs, or is it like, hey, we already know what they are and they're already like listed above? I guess I'm not sure. I'm gonna say I'm
Okay,
not
you're
sure.
on the right track that we need to take in an input, right?
Okay,
We need an input.
then it's top, mid, and bot. It would yeah,
Top,
that
mid, and bot. And
helps.
what's the name for top, mid, and bot? Like, what's the name that we assign to?
Yeah, red, yellow, and green are what they contain.
Yeah, so top, mid, and bot, they don't exist simultaneously, right? It's only one of them at any point in time.
Okay.
So what's the name of the data definition that describes that?
So okay, so you only want me to take in one color at a time. So basically, I think I understand task better. So if I receive a color like red, red becomes yellow. If I receive yellow, it becomes green, so on and so forth.
Hmm.
Or green becomes yellow, yellow becomes red, looking at the instructions. Okay, so I'm getting one color, so we can just call
Okay.
this color.
So I
I
wouldn't call it, you are correct that we are taking in a color, but I prefer to use the vocabulary that we have built up so far. What do we call uh one of red, yellow, or green?
um traffic light.
So
Well,
yeah, I prefer to call it traffic light.
all right.
And I'll explain why in a moment, but yeah, so traffic light. And let's write the signature. So like for example, Fahrenheit to Celsius on line 46, we have the signature on line 44.
Okay.
So yeah, can we run an equivalent for that?
Yeah. I guess depends on the color. Like I don't know. Do you want this in commented?
Yes. Okay. So for signature, we want to use the data definitions or types that we've defined so far. So for example, in Fahrenheit to Celsius, I wrote temperature, right? I didn't write like a specific value.
Okay. Yeah, like line 44 again.
So I'll,
Temperature to I because I'm gonna be honest, if I had wrote that signature, I would have put like temperature to temperature, or Fahrenheit to Celsius. It was to me the way you wrote it was a little weird. Like yeah, temperature. It was already a number, and now it's going to a number. Like well, yeah.
so yeah, let's stay on that for a second. So line 44 temperature. Why did I decide to write temperature to number rather than number to number? So first, why did I write temperature? The reason why I wrote temperature is because I want to refer to line 20 and 21. I'm not referring to a data representation, I'm referring to a data definition. That number has more meaning to it. It's in Fahrenheit.
Okay.
Yeah. Why does it produce a number? Now, here's the thing. I could also define a different data definition that's temperature, but for Celsius.
Okay.
I chose not
So
to just to simplify things, but I definitely could have done that.
all right. So you want to be like traffic light
Yep.
to string.
So does it produce a string?
Um. Yeah.
Okay, but technically it's something a bit more like it's not just any string, right? Like we can't produce banana. We can only produce one of red, yellow, or green.
Okay. So color.
But that's not the vocabulary we'll be using, right? We we can't make purple, for example. We can only do red, yellow, or green. And what's the name for that data definition?
Um. I'm calling them traffic lights, but I'm pretty sure you don't want me to use traffic light, so I'm not really
It
sure what to
it is
do.
traffic light to traffic light, actually. Yeah.
Okay.
Um, I also do want to use the casing that we used on line 63. So notice how we say a traffic light is one of, and traffic light is like capital T, capital L, no spaces.
Can we, can we just stop for a second? I feel like I'm hearing you and I'm kind of taking this information, but I'm not getting it. Like the overall concept, this feels very arbitrary to me, and I don't know like why we're doing some of these things.
So in what feels arbitrary?
Like this part, oh, traffic light, we're gonna make this definition, and like this means almost nothing to me. Like I get it, yes, we're going from a green to, but okay, I'm gonna take time to write this out. And it's like, and I'm just trying to like I want to understand the like just make sure I understand the concepts behind like what we're doing.
Okay, let's hold in on one specific thing. What's one specific thing that I could explain more on?
Um, like okay, like I guess I'm just no worries.
So what's one specific thing that I could explain more on?
Okay, I guess what I'm trying to get at is like, all right, you have me do this thing where I'm writing this. What is it called? The signature line,
Yes.
right? And like, I feel like I'm borderline guessing. Like, I barely know what you want the answer to be. And like, where I can tell, like, it's very obvious to you, like, oh yeah, it should be this and this. And that's not my typical academic experience. I'm usually um, I do well in academic settings. And so usually if like, oh yeah, oh this is the question, boom, oh obviously it's A and B. This is what it should be. And I'm like you're having to like literally pull like hold me by the hand to get me here. And I'm like, what is happening? Why am I not on the same page? Does that make sense?
Um, so let's talk about this signature. Like, I feel like you did it correctly, right? It's traffic light to traffic
Yeah,
light. But
sure.
are you asking like why is it traffic light and not anything else?
I guess. Sure. And like why I know you said like temp and you said temperature, you took it from like an earlier definition of like what. Oh man, there's like so much stuff written down. Temperature is a number. He said temperature, to number. Even this, like this, just again, this feels just a little arbitrary to me. This makes a little more sense. Like, yeah, yeah, sure, it is going for traffic light, traffic light. I see that. It's more of a hindsight thing. Um,
Okay. Wait, is the question like the design of the data definitions? Like, why is it that we came up with red, yellow, green? Why did we
no, of
decide
course
to?
we know what a traffic light is. Um, I mean, I guess I'm probably good to just skip and go into the function. I just want to make sure I'm understanding. I want to be on the same page with you. I want to understand what you're trying to,
Okay. So
But
far, I
I
think
know
you
we
are
got limited time. I
understanding.
don't want. Okay, okay, we let it go then. No biggie.
Okay.
Keep moving.
Okay, but the traffic light, like, does this make sense? Like this idea that we're taking in a traffic light and we're producing a traffic light.
Yes.
Okay. So right now the traffic light, notice how like the casing is like we have a space in the middle and the T and L is not capitalized.
What are we looking at?
So line 84 traffic light, it's there's a
Yeah.
space in between the two words. But
Yes.
I actually want these to refer to our definition on line 63. That's a traffic light is one of red, yellow, green.
I see. Okay.
So yeah, could we have the casing match?
See, like that wasn't like readily obvious to me that these were referring to a specific, like, oh, this is referring specifically to this, not just the word traffic light.
Yeah.
Got it.
Yeah, like I think part of it is also because like um I've done this like a few times, but I'm not like the most experienced with teaching this idea. So
Yeah, no
if
worries.
there's like rough spots, it is on me, and I'm sorry for that.
Yeah, no
But
worries.
we'll try to make the most out of what we can.
Mm-hmm.
Okay, but so far that makes sense, right? Line 84, this traffic light is referring to the definition that we have defined on line 63.
Got it. Okay.
Okay. So we call this the signature of the function. It's specifying the inputs and outputs of the function in terms of things that the computer understands. So we're saying traffic light, which is specifically red, yellow, green. This is what the function is dealing with, right?
Yeah. Okay.
Okay, so what's the next step in the design recipe for functions after signature?
Um, we got to put the test statement together.
That's one thing before the test, actually.
Okay. Examples of the data definition.
Uh, so if you look at the function design recipe on line 33 to 40, we just finished step one. What is step two?
Purpose statement. What is the purpose of the function?
Yes.
Mm, How do we understand it? Um, okay. No, I'm sorry. Okay. Yeah. So, basically, how we understand it is, yeah, traffic lights, they convert from one light to the next and go through that cycle, and we want to record that cycle in this function.
Perfect. Yeah, let's write that down.
Okay. Um, cool. Okay.
Perfect.
This,
What's
this
the
might
next step? Hmm.
Um, let's see. Examples. Now we can do examples and tests. It might sound really silly. Like when you first gave me the task, I guess I thought of traffic lights like all three. And so we're like, oh yeah, make green yellow. I'm thinking like green and yellow are literally swapping positions, not like, oh, this one's not lighting up and this was lighting up now. But now I get what you mean by that now. Like that makes more sense.
I see.
I, I don't know, probably silly. I mean, it's kind of how I took it. Um, okay,
I might do that later, actually. So hold that thought, what you mentioned just now about like, oh, red and green swapping positions. I might actually do that later with you.
sure. Okay.
Okay.
Okay. So, right. Actually, yeah, below them, all this. We do three of these.
Nice. Okay. So let's use the examples we've made. Remember, like typo problems, right?
Oh yeah, you want me to use the variables we set? My bad.
Yeah, they're all good.
Let's see.
Beautiful.
Yeah, okay.
I like how you exhausted all the possibilities as well. That's very nice.
Yeah,
All right, what's the next step?
we write the code.
Excellent.
Um, I guess we can just do this in three, like two lines, and then an else statement. So yeah, well, yeah. If here, is it better to refer to the variables? I guess yeah, right?
Yes, yeah. So that way, if we change green to blue, this will still work. We don't have to change each and every function.
Got it. Yeah. Okay. Be nice. Oh wait, do we have to? Do I? Is that sufficient to close that out in this language? Or do I need to put something in to close out an if statement?
No, you can write else if next.
Oh wait, I know better. My bad. So yeah, that should do it.
Great. Okay. Let's run this. Oh, you need to add an end after line 92 to end the if expression.
Okay.
Perfect.
Something like
Okay,
that.
so in this language, you do not have to write return.
That's right.
Yeah,
I can just put top.
yeah. And same for the other two.
Okay.
Excellent. Okay, so
Everything
this is
looks good.
absolutely correct. But I'm going to talk about some things that's going to sound crazy, that or at least might sound crazy. So the first thing I want to talk about is, in our data definition in line 63 to 66, notice how we have red, yellow, then green?
Yeah.
Okay, I know this sounds very funny, but I prefer if we have line 87 to line 93 mirror them as much as possible. So I kind of want to check top and then check mid and then check bot.
Okay.
Okay, what I just said is just an aesthetic thing, but I will talk more about that. But can we change that? Can we change the top one to the first if condition to be check for top,
Sure.
essentially swapping the first and last conditions?
Yeah.
I believe we got to change to line 92 as well.
Mm-hmm.
Okay, very good. Okay, and I know this sounds again very funny, but back to this idea of mirroring lines 87 to line 93 to the data definition, I would like the last the else on line 91. I would like that to be an else if traffic light double equals spot. And that's gonna sound contentious, but could we try that for a second?
Okay. Um, yeah. So, okay, so you want instead of like else, you want else if
Yep,
and the same thing. Okay.
exactly. Yeah. Okay. I think the line 91, the else if, the if must be lowercase.
Oh, my bad.
All good. Perfect.
Yeah.
Okay, so
I
what's
will
the
say is,
difference? Sorry, go ahead.
I will say it's something I have to get used to. I'm not used to writing. I almost exclusively write all my variables in lowercase. I almost
Ah,
and so switching back and forth between lowercase and uppercase will be
mm,
I have to get used to that again, or just get used to that in general.
it comes with time. Okay.
Yeah, the constant.
So
Okay.
what's the difference between line 91 having that more specific else if traffic light bot as opposed to else? What's the difference? I'll be writing this down as well.
So if a fourth condition, okay, so like else, the difference between else if is more specific, which means hey, if you see this, do this.
Hmm?
The else if, but the else is not specific. It basically means if you don't meet these other two conditions, any other conditions is gonna do this. So if somehow a fourth or fifth or sixth condition came up, they would still generate the same else. So I don't know if there was some other
Okay.
country that had four traffic lights, and I guess technically, if even in America, you can argue there are some like that. If you start including, turn arrows and U-turns, I've seen those too.
No, that's a very good point. So if we decide to add more cases to the enumeration,
Yeah,
like for
exactly.
example, let's say we decide to add like blue to our traffic light. So on line 98, and this is just, I'm going to delete this later. And let's say blue is meant to be blue. Okay, let's just say.
Yeah.
What do we get?
Um, it's gonna be false. Or in this
Actually,
case, I don't,
we get an
we
exception.
don't. Yeah, it would have been false on my code the way I originally wrote it because it would have came back at whatever I put for the else statement, which
Yes.
I think was bot.
So it's the difference between getting an exception or the wrong value. So in this case of this language, that barely makes a difference. But there are other languages that have stronger type systems
Hmm.
where, like, if you try to run it, it'll say, hey, look, you forgot to fill in a case here. Can you fill in a case there? For example, I don't know, have you heard of OCaml
Yes, yeah, that's more common with JavaScript.
or TypeScript,
Hmm?
right? With TypeScript.
Oh, you mean like um having the casing all be camel type? Oh,
Oh, no,
OCaml. Okay, never
OCaml.
mind. We're thinking of two different things. I'm sorry. No, I don't know
Uh,
what that is.
OCaml. Oh,
I
it's
thought
a
you were talking about
programming
cam.
language. Yeah.
No, never heard of it.
All good, all good. Yeah, it's a very fun language. I recommend you check it out one day. But
Awesome.
yes, so these language features, they're just tools, and as programmers, we use the tools to our benefit. Um, there may be times where else is actually better. Um, in this case, I actually do prefer else if, actually for one reason. The else if mirrors the data definition. And this, I want to end
Right.
this session with this idea. Um, the, s- the structure of the function follows the structure of the data definition. Okay, this is a
Mm-hmm.
very important idea. So I'm going to change the body of rotate traffic light by doing this. Um, real quick. Do you see what I'm doing?
Um,
Why is the why is the bot not aligned? Okay, anyway, you see that?
kind of.
And can you compare lines 87 to 89 with 64 to 66? Do you see that parallel relationship?
Yes.
So how a function looks mirrors how our data definition looks. You see that?
Okay. Yeah.
This is a very, very important idea throughout our sessions. And we'll keep working on that idea.
Oh, yours.
I'm not the only one that sees that, right?
You like for me, if I shared my screen, it's like
Uh-huh.
V three spaces OT, and then like
Interesting.
and then
I,
like there's no T next to op. Yeah. Okay.
interesting.
So it's bugging a little bit.
Okay, you can change it as you wish since you're the one saving the file on your end. Uh,
I think it's
okay. For
wait, no, five space. Is it supposed to be space after the colon? I'm
I
assuming yes.
personally prefer if there's space after the colon, but I think it will parse regardless.
Okay.
Okay, for homework, I don't actually have a lot of homework. I can give if you want more work, I can assign you reading, but like, this is like really optional homework. Homework if you have time. Design a function, uh, tra traffic light to image that produces the corresponding traffic light for image for the given traffic light. Does that make
Okay. So
sense?
you put the string in or the variable for red, and then the image has to be produced.
Yes. It's
Okay.
up to you how you want to design it. The simplest is just to have a red circle or a yellow
Exactly.
circle. You can also decide to have three circles on top of one another, and the others, like red would be highlighted if it's red, and then the rest are like dull. You can also choose to do that. I'll leave this up to you, your artistic expertise.
All right. Sounds good.
Okay. I don't have any sessions right now, so do you have any questions before we end it?
Um, can I ask you like I want to translate the test. This is a little more related to Python, but I want to
Mhm.
translate how I'm testing here. So like how I'm testing in Python. I can't really quite get it. Can I ask you about
Mhm.
that?
Yeah, sure. So testing in Python, I can send you a page. Okay, actually, let me send you a page. Give me 1 second. Yeah, I got extra time right now. I don't have a student. You're my last student of the day.
Nice. Okay.
Give me let me pull up something. I'll talk a little bit about it, and I'll send you a page where you can learn more about it. Um,
Okay. Um,
I found it. I have found it.
that's
Okay, so I'm sharing my screen
vanity
right
shit.
now.
Man.
So this is one of the textbooks that I base my sessions on. It's booked by multiple people. I know a lot of people from Brown University, for some definition of a
Nice.
lot, work on this. So part of Pyret is actually designed to transition you to Python. That's why they have the word PY in the name.
Okay.
Uh,
That's good to know.
let's see. So there's a whole section dedicated. So if you look at overall, there's a lot of sections. Uh, what we've been covering so far is a little bit from chapter 2 and also from a different textbook. But what you want to look at is chapter 3 from Pyret to Python. Um, there are many things here. One of it, the one that you asked me about, is examples and test cases. So in Pyret, testing is a built-in functionality. Like there's like special syntax for it. This is not the case in Python. In Python, you need to import a library, or in Python they call it package. You import a package. So this is like code that other people wrote that allows you to do testing. It's not part of the language. This is like community driven. It's
Okay.
like batteries, like it's something you plug in outside of the language.
Yeah.
Uh, the common one is PyTest. There are a few alternatives. I forgot them all. I remember PyTest. Uh,
Okay, but still, like that, even that context is super helpful because,
yeah.
like I'm kind of seeing what you're talking about when I'm looking into this. I'm like, why, like what? It's so like, why doesn't this translate so directly? And now, okay, that makes sense. You have to import like you do with math. You have to import a library.
Exactly, yes. So you gotta import the pack. So first you need to install it, like pip install. Once you pip install, then you can import it. If you don't pip install, it will say, "Oh, I don't know what this is." You gotta install it.
If I type import PyTest, will VS Code prompt me to install it?
I think it might. Yeah, if you install the Python extension. Yeah.
I'm pretty sure already have that installed. If I'm not mistaken. So I
Okay.
might just already have it. And that is import just no.
And another thing to notice, there is no where clause. There's no where block. Like in PyTest, you
Yeah.
can write where. That does not exist in Python because this is not, there's no special syntax for this. It's where you
Yeah.
operating within the normal syntax of Python. So you actually have to write a new function. And I
Okay.
believe it must begin with test underscore. This is an indication to the package that, oh, this is a test. Please run the test for me.
Okay.
Yeah.
Okay. I
Yes.
I've been using these as assert lines, but
Mhm.
like nothing goes to I don't know the recorder. I forget the thing that runs the program. Uh, what do we call that again? The part that runs the that runs the code.
Oh, like the is?
No,
Like,
like when you hit like when you hit like run the code and then it gives you the answers to your functions. That side of the web development tool.
oh, the REPL?
I think it REPL, sure. That's
But yeah, I know what you're talking
um
about, where it gives you the answers, yeah.
I'm just trying yeah, I'm trying to get my lingo and language down too. Um and it was yeah, nothing happens on that side. I'm like, this isn't working. I like but okay, but so yeah, so okay, so I need to wrap this inside I need to wrap this inside of a function. Yeah, so
Yeah.
I can try that now.
So you're wrapping the function, it has to start with test underscore. That's very important. Otherwise, the package doesn't know to look at it.
Okay.
Once you do that, the is, instead of an is, we use assert double equals. Um, Instead of double equals, you might find other forms of comparisons. But yeah, I'll send this to you as well. I'll send it to your Gmail.
I appreciate
Okay,
it. Thank you.
all right, let's wrap it up here. I hope you learned something today, and we'll pick it back up next time.
I appreciate it. Thank you so much for your
No
time and
problem, man.
everything you taught me.
Of course, man. All right, see you, Ernesto.
Have a good day. Bye.